Assalamualaikum warahmatullahi wabarakatuh. Welcome to chemistry class with Miss Lia. Hi student, how is everyone doing? I hope all of you are doing alright and ready to study. First of all, I want you to set up your study space. Please make sure you are far away from any kind of distraction. Are you ready? Today's topic is quantum numbers. What are quantum numbers? When you want to go to your friend's house for the first time, you will need an address. An address will let you know where your friend lives on the earth. Unlike coordinate which will give a definite point, the address only gives information on the area where your friends live. He can be in the room, in the living room, or the yard. You don't know the exact point where he is. The same concept also happens in atom. In the atom, we have electron cloud that illustrate the orbital. The orbital is the area where we can find an electron. If the house has an address, the orbital number has quantum numbers. So, quantum numbers provide information similar to an address. We cannot know the exact position of the electrons, but we can know the area where an electron is likely to be found. This area can be described using quantum numbers. So we will go on to the first quantum numbers. The first quantum number is principal quantum number or N. This quantum number defines the location of the energy level or electron shell. So we also can call it the shell number. This is the same shell that we're talking about. So if we have an electron in the first cell, the N will equal 1. If we have electron in the second cell, so N will be 2, and so on. The next is angular momentum quantum number or L. It is also called azimuthal quantum number. It describes the shape of the orbital. Orbitals with the same value of L determine a subshell. So if we have L equal 0, it will be S subshell, and if the L equal 1, it will be P subshell with 3 different orientations. We have Px, Py, and Pz, and we have 5 different orbitals for d orbital, but all of these orbitals have L equal 2, so it will be in the G subshell. We also have F orbitals that contain 7 kinds of orbitals, but all of them in the L equal 3, so it is in the F subshell. So F subshell contains 7 orbitals in it. To make it simple, this 4th subshell will be drawn using orbital diagram. For the S orbital, we have 1 kind of orbital, so we will draw it as 1 square. For the P, we have 3 kind different of orbital, so we will draw it as 3 square. These 3 square represent P orbital or P subshell. The next we have G subshell with 5 different orbitals, so will be 5 squared. The last we have F orbital. It contains 7 kind of orbitals, so the square will be 7 too. The next is magnetic quantum number. The magnetic quantum number, or M, specifies the relative spatial orientation of a particular orbital. The M will value from -L to +L. For the S subshell with 1 orbital and L equals 0, so M will be 0. Remember, M will value for -L to +L. The next P subshell contains 3 kind of orbital with L equal 1, so the M will be value from -1 to +1 because L is 1. And the next, the G subshell contains 5 orbitals, so it will be from -2 into +2. The last is spin quantum number. Spin quantum number represents the spin of the electron. Electron is negative, so each electron will repel each other. So if one electron spin up, the other will spin down. The spin up electron will have S equal a half, and the spin down, the S equal minus a half. So here in this summary, we have 4 quantum numbers to describe the electron. And how to write electron configuration of the element? To write electron configuration, there are 3 rules. The first rule is Pauli exclusion principle. This Pauli exclusion principle says that no 2 electrons in the same atom can have exactly the same set of all the 4 quantum numbers. Therefore, any atomic orbital has only 2 maximum electrons because it is only spin up and spin down, so in every orbital can only contain 2 electrons, one is spin up and one is spin down. So the S subshell contains maximum 2 electrons, and the P subshell with 3 orbitals will contain 6 electrons, and the G subshell will contain how many electrons? Yes, 10 electrons. The next is Hund's rule of maximum multiplicity. Do you notice how I throw electron in the orbital box before? Based on Hund's rules, we need to throw electron one by one in their subshell before pairing them, because pairing of electron in a subshell starts after all the available atomic orbital on the subshell are half filled. For example, we have p orbital. The wrong way is we pairing first the electron. It is wrong. We should throw one by one electron. The last is Aufbau principle. Aufbau from the German word, it is mean to build up. Electron is added from the lowest energy level, which is the 1s, to the highest energy level, following this line. There are some information you need to know. In 1s to it is one that represents the shell or principal quantum number, and the S represents the subshell. It can be S, P, G, F, or etc. And the two number represent the electron. For example, we have lithium with 3 electrons. We will start the configuration from 1s2. In the S subshell, there are 2 electrons maximum. We will write 1s2, 2 electrons already added, and we have 1 remaining electron for lithium. So in the 2s, we only write 1 because lithium only contains 3 electrons. We add 2 electrons in the first and 1 electron in the second shell. So it is the lithium. Next, oxygen with electron 8. Again, we start from 1s2 and 2s2, and we still have 4 electrons because it is 4 already, and we will go to the next. The next is 2p6, but again in oxygen there are only 8 electrons, so we only need to put 4 here. So we will make 8 electrons distribute in these 3 subshells. Next, we will try to make orbital diagram. If we have nitrogen, the electron is 7, and the configuration will be 1s2, 2s2, 2p, 3, just 3, and S1 box we put the electron, and 2s also has 2 electrons. In the p, it is 3 electrons. We draw all of the electrons up, and this is the orbital diagram of nitrogen. We can simplify our electron configuration using noble gas. Noble gas is a group in the periodic table that the electron configuration is already full in every orbitals. It is contain helium, neon, argon, krypton, and etc. So the noble gas is like a shortcut. We make the long configuration become simple. And how we can draw this simple configuration? Please take a look. So this is the shortcut. Helium will shortcut from 2s, neon will shortcut from 3s, argon will shortcut from 4s, and so on. The shortcut is from the electron that noble gas has. Okay, let's practice. We have ferrum with 26 electrons. We can shortcut this configuration using noble gas, which has electron lower than ferrum. The nearest one is argon, so we will shortcut with argon. Ferrum, if we shortcut with argon, so we don't need to write from 1s, we should write from 4s2. And argon has 18 electrons. From the 26 electrons of ferrum, we still have 8 electrons remain. So we will go to the 4s and then write the remaining electron. Configuration will be for S2 and 3G6. If we sum all of the electrons. For argon, 18, for S has 2, and 3D has 6. 18 plus 2 plus 6 is 26. There are some anomalies in electron configuration. The first is half-full J subshell. If you found J4, you should make it into J5. For example, we have copper with 24 electrons. The configuration it should be Ar, 4s2, 3d4, but it is not correct. The correct one is you move the one electron in the S subshell into the J. So in S it will become 1 and the J become 5. It is always like that. And the second anomaly is completely full J subshell. If you find J9, you should make it into J10. G10 I mean. For example, we have chromium with 29 electrons. We expect that the electron configuration will be argon and then 4s2 3d9, but the actual configuration is argon 4s1 and 3d10. So we move the S again into the G. So it will be 4s1 and 3d10. It is always like that. Do you still remember quantum numbers? Okay, we will try to deducing quantum numbers from the electron configuration. In this first case, you should deduce for quantum numbers of the last electron from calcium. Because it is the last electron, you should make electron configuration first. The calcium contains 20 electrons. It will be N in 4s2. In the 4s2, we have 4. It is represent the principal quantum number N. So the N is 4. And S, the subshell S, it represent the angular momentum quantum number, or L. L is 0, and these 2 electrons we can draw the diagram first. It is S, so contain 1 square, and then we put the electron, it contains 2 electrons, so the magnetic quantum number is 0 because it is S, and spin quantum number is minus half. It is because the last electron is spin down. Second case, we have iron with 26. We will make the configuration first, like before. It is will end in 3d6. So from 3d6, the 3 represent the principal quantum number, and the N will be 3. The next is G. Because it is G, so the angular momentum quantum numbers will be 2. And from the 6 electron, we will draw first. We put the 6 electron into each orbital one by one first, and the M can be from 0 in the middle, and negative into the left, and positive into the right, and our electron and in minus 2. So the M will be minus 2, and the spin will be minus a half because it is spin down. So the next, deducing the element from quantum numbers. We already have 4 quantum numbers and we need to deduce what element it is. So we should identify. The N is 3, it means that the electron is in the 3rd cell, and we will write 3 from the shell, and the L is 2. It means that it is G subshell. S is 0, P is 1, and G is 2, so it is G subshell. And M is -1. It means that the electron is in the second orbital of G subshell. We will draw it, and the S is -½ so it means that the last electron is pinned down. Minus, so it is down. G subshell contains 5 orbitals, and the M will be valued from -2 into +2 because our orbital is ending in the M with -1, so it will ending here. And our electron is pinned down, so the electron filled in this subshell is 7, so the D is 7. It is ending in -1, and the last electron is pinned down, so it is filled with 7 electrons. So in the last subshell is 3d7. From 3d7 we should make it from 1s2 until 3d7. How much electron it is? We fill from 1s into 3d7, and we will cut 27 electrons. Element with atomic number 27 is cobalt, so this is configuration of cobalt. Thank you for your attention. Terima kasih. Don't forget to practice after this. Wassalamualaikum warahmatullahi wabarakatuh.